Hello everyone, welcome to the Unacademy. All of you, am I audible? Please respond me so that I can start the session. All of you, am I audible or not? Respond me as soon as possible. Saurabh, welcome Saurabh. Hello. Okay, let's crack GATE ESE with India's largest online learning platform. Get the Plus subscription now and start accessing the unlimited live and the recorded video lectures by the India's best educators. So myself Ajay Das, I am MTech in Computer Science. I have a teaching experience of 8 plus year and till now I have trained almost 20,000 plus engineering students for the GATE training and placement PSUs UGC NET. So I have worked as a freelancer in many reputed institutes of India across the India. Like I have also qualified the GATE exam 5 times below the AIR 500 and qualified the Chhattisgarh State Electricity Board exam with AIR 8 in 2010. So download the Unacademy learning app and start your preparation sitting anywhere, anytime. What you will get? This is the major question which always used to arise in everyone's minds. So my dear friends, inside the Unacademy platform there are two different kind of subscription model. One is the plus, second one is the iconic. So if we will talk about the plus, then all these four features are included inside the plus courses. First one is the daily life classes, structure courses, live test and quizzes, unlimited access. So these are the things you are going to have in a plus courses whose fees is just minimal, nominal. But if you are looking for the iconic courses, so there along with these features you are going to have one additional things. Of course there are many more additional things, but which is the important is the personalized coach. Means you are going to have a personal coach for your training and the preparations. So my dear friends, apart from these you are going to have India's best educators. So I have listed only few of the educators who are associated with the Unacademy. To know more about the educators, what you can do, you can download the Unacademy learning app and you can check the profile of each and every educators, what are like their experience, what are their history means what kind of result they have produced in their career. So if you want to explore more thing about the faculty according to your branch, you can download the Unacademy learning app. You can see the profile of each and every faculty and you can judge the quality of which Unacademy is providing you. So under the GATE ESE, as you know, there are various branches. So what, for which branches the Unacademy making you prepared for the GATE and ESE, you can look upon over here. So here it is a mechanical, computer science, okay, electrical and instrumentation, production, chemical. So there are various branches for which Unacademy is preparing you for the GATE and ESE. So you can subscribe and you can suggest your friends according to their branches. Got it? Now let's come to the subscription model. My dear friends, never forget to use the code IFA to get the minimum 10% discount. How much? Minimum 10% discount. So these are the subscription model of the plus courses. So if you are taking the subscription for the 1 month, your fees is 5,500. Similarly for the 3 months, 6 month and 12 month. So any competitive exam require the 1 year of dedication. So if you really want to make some history in the final GATE exam, then must go for the 12 month of subscription and your fee structure will be 40,500. But once you will apply this code, you will immediately get the minimum 10% discount. Why I am saying minimum, you can personally text me for the more information about the subscription and all. But if you are looking for the GATE 2022, in that situation, then you either you can go for the 18 months or the 24 months. So if you are taking the subscription for the 18 month, your fee structure will be 38,500. Similarly for the 24 month, your fee structure will be 44,000. So my dear friends, once again I will tell you, you will apply the code IFA, your fees will become here after the 10% discount 49,600. So let's me introduce the discounted fees after applying the code IFA. So these are the discounted fees month-wise. So just see over here, for the 12 month of subscription, after applying the code IFA, your fee will become the 49,500. One additional thing I will tell you, these are the fee structure for the plus subscription and this code which is written over here, this is not only for the GATE and ESE. If any of your friends who are looking for the UPSC, CAT, JRE and like banking, CGL, IIT, JEE, NEET, whatever it is, whatever the courses which are available in Unacademy platform, all of them can use the code IFA to get minimum 10% discount. Okay, so just remove the misconception that this particular code is only applicable for the GATE and ESE. No, it is applicable for the all courses which is available in Unacademy platform. So you can suggest your friends and relatives. So now let's see about the iconic. So here I am going to describe you about the iconic. So in the iconic courses, there is no any month-wise subscription model. So if you want to subscribe for the iconic courses, there is only two model. One is the 12 month of subscription. Second one is the 24 month of subscription. I know this is the basic process, Saurabh. This is the basic process, and some of the student has to know. That's why we should spend some time. So have some patience of 2 to 3 minutes. I will start the session. Not a problem at all. Okay. So if you are looking for the like iconic courses, then for the 12 month your fee structure will be 45,000, and if you are looking for the 24 month your fee structure will be 60,000, right? So let's see what additional features you are going to have inside the iconic courses. So again, my dear friends, once you will apply the code IFA, you will get minimum 10% discount. Once you will apply the code IFA, which is already I have mentioned, you will get minimum 10% of discount. So let's see over here. So inside the plus courses, already we know we will get the best educators, interactive live session, structured courses and PDF live test and quizzes and unlimited access. But in iconic courses, you will get all these things. Apart from this, you are going to have a personal coach, personalized test analysis, study planner, preparatory study material. So you are going to have a study material and personal coach. The personal coach means the person or the teacher who will guide you time to time according to your performance. So these are the additional features that you are going to have in an iconic subscription. So to get the better rank in your final target, you have to follow the iconic courses. That is my personal advice. So you can choose your personal course according to your comfortability. There are various educators, whatever you want you can choose. Means जिसमें आप comfortable feel कर रहे हो, जो आपको लगता है कि आपको अच्छे से ट्रेंड कर सकता है, आपको बेहतर तरीके से गाइड कर सकता है, you can choose that coach as your personal coach, right? Now let's come to the subject. So let's crack it. My dear friends, our today's topic is algorithm, and it is a marathon course. I'm going to take the classes or the session of 3 hours where I will explain the entire thing of the complexity analysis. So this is the marathon course of complexity analysis. So चलिए सबसे पहले हम लोग देखते हैं कि complexity analysis में हम लोग को पढ़ना क्या है, ठीक है ना? Complexity analysis is basically means the time complexity is basically done for two kind of program. One is the iterative program, fine, and second one is the recursive program. So my dear friend, जब भी हम लोग कोई भी प्रोग्राम लिखते हैं तो वो प्रोग्राम या तो इटरेटिव होता है या तो रिकर्सिव होता है, ठीक है ना? तो इटरेटिव प्रोग्राम मीन्स यू कैन से विदाउट रिकर्शन, जो प्रोग्राम सिंपल फॉर्म में लिखा जाता है. तो किसी भी इटरेटिव प्रोग्राम का टाइम कॉम्प्लेक्सिटी फाइंड आउट करने का तरीका क्या होगा? हाउ टू फाइंड आउट टाइम कॉम्प्लेक्सिटी of iterative program and how to find out the time complexity of the recursive program. So आज का हमारा जो major discussion होगा वो इस वाले पार्ट पे. We will look upon some of the questions of iterative part, but we will more focus on the recursive part, क्योंकि गेट के लगभग 70% क्वेश्चंस इस पर्टिकुलर टॉपिक से होता है और 30% क्वेश्चंस इस पर्टिकुलर टॉपिक से होता है. मीन्स if you will look upon the pattern of the gate, you will be able to realize कि यहां से एक क्वेश्चंस आते हैं, ठीक है ना? और यहां से आपको बेसिकली 2 से 3 क्वेश्चंस मिलेंगे इन योर गेट एग्जाम. नाउ यू कैन इमेजिन what is the importance of the complexity analysis in your gate paper. Got it? So the question is how to find out the time complexity of the recursive program. There are 3 different approach. The first one is the substitution method. ठीक है ना, one by one I will explain each and every method. Okay. Second one is master theorem. And the third one is recursive tree method. Recursive tree method. Okay, what does it mean? Means by this method we are trying to find out, by this all method we are trying to find out the time complexity. Let me tell you one simple example of iterative program and recursive program, then you will be able to understand. Then I will start each and every method. So first of all, let's try to feel what is the meaning of iterative program and what is the meaning of recursive program and how we are trying to find out the time complexity. So first of all, we will try to realize these things and then we will start one by one the substitution, master theorem and recursive tree method. So let's see. See, my dear friends, if I am talking about the iterative program, just see over here. I'm writing 2 different programs. One is the iterative program. Write it. Okay, int I, j, n, scanf, %d, address of n, for loop, I is equal to 0, I less than n, and I plus plus, and then while loop. This is the suppose m is equal to n. While loop m is greater than 0 and m is equal to m by, is that fine? That fine. So just consider one more variable of name m. This is the n, and so this is just a iterative program. Means in iterative program we will never use the recursion. Means we can use the for loop, while loop, whatever you want you can use over here, go to statement, anything. So let's try to analyze the time complexity of this particular program. So my dear friends, look upon this for loop. How many times this particular for loop will be executed? Of course the n times, because we are starting from the 0, I is equal to 0, and we are moving up to the n minus 1. Means how many times this particular for loop will be executed? N times. Similarly, let's see how many times this particular loop will be executed. Just see over here. See, if you are considering the value of m is equal to suppose 16, means actually the value of n is equal to m and that is equal to 16. So of course 16 is greater than 0, the condition is true, the loop will be executed. Next time the value will become 8 is greater than 0, condition is true. Next time it will become 4 is greater than 0, it is true. Next time it will become 2 is greater than 0, true. Again 1 is greater than 0, true. Again 0 is greater than 0, this condition is false. This particular condition is false. So how many times the loop is being executed? Just see over here. 1, 2, 3, 4, 5. The loop is executing 5 times whenever we are considering the value of m is equal to 16. Similarly, if you will consider the value of n is equal to m is equal to, of course, you can write the 16 in the form of 2 to the power 4. Similarly, if you will consider the 2 to the power 10, that is nothing but 1024, then the loop will execute how much time? 11 times. So ultimately what we are getting, the loop is executing almost, you can say almost log of n on the base 2 times. Are you getting my point or not? So once you will take the log of these particular things, if this is the value of m and you will take the log of this, it will become 4. If you will take the log of this, it will become 10. Are you getting my point or not? Of course, actual value is coming out to be 11. So 11 is almost equivalent to 10. We can imagine whenever we are trying to find out the time complexity. Got it, everyone? So ultimately here we can write it is executing log of n on the base 2 times. Log of n on the base 2 times. Clear, everyone? Now let's try to find out the actual time complexity. Just see over here. See, आउटर जो फॉर लूप है, यहां पर i इक्वल टू 0 जब हम लोग लेंगे तो हम लोग इनर लूप पे आ रहे हैं, और इनर लूप कितने टाइम चल रहा है? लॉग ऑफ n टाइम्स. नेक्स्ट टाइम i का वैल्यू कितना हो जाएगा? 1. फिर से ये लूप ऊपर जाएगा, नेक्स्ट वैल्यू ऑफ i विल बिकम 1, और फिर 1 लेकर के नीचे आएंगे. ये लूप कितने टाइम चलेगा? अगेन लॉग ऑफ n टाइम्स. फिर i का वैल्यू कितना हो जाएगा? 2. इनर लूप कितने टाइम चलेगा? लॉग ऑफ n टाइम. सिमिलरली ये ऐसे बढ़ते बढ़ते i का वैल्यू कितना हो जाएगा? n minus 1, and the inner loop will be executed up to the log of n times. So this is nothing but the outer loop, and this is nothing but the inner loop. So how many times the inner loop is being executed? This much time at this value. So ultimately it will become, तो इसको हम लोग ऐड कर रहे हैं. कितने टाइम ऐड कर रहे हैं? जितने बार आउटर लूप चल रहा है. आउटर लूप कितने बार चल रहा है? n टाइम्स. तो log ऑफ n को n टाइम्स ऐड करेंगे तो ये कितना हो जाएगा? n log n. So the complexity will become order of n log n. So this is the one of the simplest example. This is the one of the simplest example related with iterative program. Now I think the concept of the iterative program is clear to all of you. Any confusion? If you have any confusion, you can ask me, all of you. बोलो भाई, समझ में आ रहा है? Now, so till now we have discussed about the iterative program. Now let's see how the recursive program basically work. Okay, see over here. See over here. Now I'm talking about recursive. Just see over here. This is the function f int. Now see, if n is less than 1, then return. Else what you have to do, you just call the same function again and again. N by 2 and again f of n by 2, and then printf star. Okay, in this manner, printf star. Now my dear friends, you can see over here you are calling the function recursively. So this is nothing but a recursive This is nothing but a recursive function. Now the question is how to find out the time complexity of the recursive function. See, how to find out the time complexity of recursive function. So first of all you have to map the recursive function into the recurrence relation, So what will be the recurrence relation of this recursive function? Suppose this function is indicated by t and we are passing the parameter n. So just write it over here. Means in the function t we are passing the parameter n. So t of n is equal to, see over here, if the value of n is less than 1 it will be returned. So it will be returned in a constant time, yes or no? Or you are calling the same function two times, with the parameter n by 2 and n by 2. So we are passing, this is the function t and this is the function also t. So we are calling the same function recursively two times with the parameter n by 2 and again with the parameter n by 2. Now plus, of course, these things will be executed on each recursive call and it can be executed in order of one time. भाई printf statement को execute करने में कितना time लगेगा? Order of one time, constant time लगेगा. So it will become order of 1. So ultimately we can write t of n is equal to 2t n by 2 and plus order of 1, or you can write c. C is nothing but a constant time. Constant time को indicate करने का तरीका होता है c. C is the constant value. So ultimately we have retained the recurrence relation. So this is nothing but a recurrence relation. Now solving this recurrence relation will give us the time complexity of the actual program. So this is the actual program. This is the actual program, and solving this recurrence relation will give us the time complexity of actual program. So just write it over here. Solving this recurrence relation will give us time complexity of actual program. तो recurrence relation किसी भी फॉर्म का जनरेट हो सकता है. प्लीज माइंड इट, द recurrence relation can be created in any one of the form. So our now ultimate objective is to find the time complexity of the recurrence relation. तो अलग अलग recurrence relation को कैसे solve करना है, for that reason we are just working on the three different method. One is the substitution method, second one is the master theorem, third one is the recursive tree method. So ये तीन अलग अलग method हम लोग क्यों सीख रहे हैं, हर एक के पीछे एक रीजन है, ठीक है ना. मास्टर थ्योरम हर एक रेफरेंस रिलेशन में अप्लाई नहीं हो सकता, एंड दैट्स व्हाई द मास्टर थ्योरम हैज सम लिमिटेशन. और इस लिमिटेशन की वजह से बहुत तरह के रेफरेंस रिलेशन होते हैं और हर रेफरेंस रिलेशन पे मास्टर थ्योरम हम लोग अप्लाई नहीं कर सकते, तो इसीलिए वहां पर हम लोग सब्स्टिट्यूशन मेथड लगाते हैं. अगेन कुछ ऐसे रेफरेंस रिलेशन है जहां पर सब्स्टिट्यूशन मेथड या मास्टर थ्योरम तो यूज होगा ही नहीं, बट सब्स्टिट्यूशन मेथड विल क्रिएट द मोर complexity means it will become more complex to solve. So in that situation we will apply the recursive tree method. Are you getting my point or not? So depending upon the situation, or you can say the problem, we will choose which recurrence relation we have to apply while solving the numerical. Got it everyone? So पहले हम लोगों ने देखा iterative method, and what we have analyzed in case of iterative method, that any iterative program can be solved by the logical thought, by the logical thinking. इसको सॉल्व करने का कोई पर्टिकुलर मेथड नहीं है, आपको प्रोग्राम को एनालाइज करना पड़ेगा एंड देन यू हैव टू सॉल्व द प्रोग्राम. बट to solve any recursive program, first of all you have to write the recurrence relation, and to solve the recurrence relation we have a three different method: substitution, master and recursive tree method. Now let's see where we have to apply the substitution method, where we have to apply the master theorem, and where we have to apply the recursive tree method. I'm just giving you an example and then we will start each and every method line by line. Just see over here. See, देखिए मैं तीन अलग अलग रेफरेंस रिलेशन ले रहा हूं. अगर रेफरेंस रिलेशन का फॉर्म कुछ ऐसा है, t of n इज इक्वल टू 2t रूट अंडर n प्लस 1. यह आपको बाद में खुद पता चल जाएगा कि कहां पर सब्स्टिट्यूशन यूज करना है. तो अगर रेफरेंस रिलेशन कुछ इस तरह का फॉर्म है तो यहां पर हम लोग प्रीफर करेंगे सब्स्टिट्यूशन मेथड अप्लाई करना. विच मेथड? Substitution. But if the recurrence relation is given in this form, ठीक है ना, like 2t n by 2 plus order of n, then here we can apply the master theorem. We can apply the master theorem. And third case is, if the recurrence relation is given as like this: t n by 4 n plus t 3n by 4 plus order of n, then we will prefer to use recursive tree method. Recursive tree. Are you getting my point or not? So depending upon the situation we will use the different methods: substitution, master and recursive tree method. So within 1 hour you will be able to realize where to use which method. So my dear friends, let's start with the basic method, that is the substitution method. Okay, fine. See you over here. Let's start with the method substitution. देखिए नाम से ही लग रहा है कि कहीं ना कहीं वैल्यू बार बार सब्स्टिट्यूट हो रहा है. वी आर सब्स्टिट्यूटिंग द वैल्यू अगेन एंड अगेन अंटिल वी गेट द आंसर. आर यू गेटिंग माय पॉइंट और नॉट? सो लेट्स टेक अ एग्जांपल. ठीक है ना, एक एग्जांपल लेते हैं. सपोज रेफरेंस रिलेशन गिवन है t of n इज इक्वल टू 2t n by 2 and plus 1. ठीक है ना, प्लस 1. नाउ सी ओवर हियर. अब हमको इसके वैल्यू को सब्स्टिट्यूट करना है. क्या करना है? वी हैव टू सब्स्टिट्यूट दिस पर्टिकुलर वैल्यू. सो व्हाट वी विल डू, यहां पर n के जगह आप n by 2 को पुट करो. तो क्या बनेगा? सी ओवर हियर, t n by 2 विल बिकम 2t. ऑफ कोर्स इस n के जगह n by 2 पुट करेंगे तो इट विल बिकम n by 2 डिवाइडेड by 2. तो प्लस 1 means what we have done, the instance of n is substituted by n by 2. So ultimately what we are getting, the n by 2 is equal to 2t. अब ये 2 नीचे आएगा और मल्टीप्लाई होगा, so it will become n by 2 square. This one will become plus 1. So finally this is the value of t n by 2. तो t n by 2 की जगह क्या वैल्यू आ रहा है? ये वैल्यू आ रहा है. तो इस वैल्यू को आपको क्या करना है? सब्स्टिट्यूट करना है. यू हैव टू सब्स्टिट्यूट दिस वैल्यू, you have to substitute this value over here. Means substitute this, and that's why we are saying the substitution method. So यहां पर ये क्या बनेगा? 2 ब्रैकेट के अंदर क्या लिखेंगे? 2t n by 2 square and plus 1. ये तो मैंने सब्स्टिट्यूट कर दिया और ये बाहर का 1 है. ठीक है ना, दिस इज द 1 आउटसाइड ऑफ दिस. So now multiply the 2 by this. What will happen? 2 square t n by 2 square and plus 2 and plus 1. So these things we are getting in first substitution. Similarly, in the second substitution, what will happen? Let's try to understand. अब हम लोग को क्या करना है? We have to substitute this value. So इस value को substitute करिए. तो 2 square. Similarly, यहाँ पर क्या आएगा? 2t n by 2 to the power 3. भाई अब n के जगह n by 2 square आप substitute करोगे तो क्या आएगा? n by 2 to the power 3 and plus 1. Means in this place we will place the n by 2 square. So we will get 2t n by 2 square यहाँ पर आएगा, ये नीचे multiply होगा, 2 to the power क्या आ जाएगा? 3 आ जाएगा. Are you getting my point or not? So again the outside of this there is a plus 2 and plus 1. Now multiply this. It will become 2 to the power 3 t n by 2 to the power 3 and plus 2 square and plus 2 and plus. So these things or this result we are getting in second substitution. So अब इसके पैटर्न को समझिए. पैटर्न क्या है कि पहले सब्स्टिट्यूशन में यहां पर ये पावर 2 आ रहा है और ये भी पावर 2 आ रहा है और ये पावर 1 है. 1 का मतलब क्या हो जाता है? 2 to the power 0. मीन्स ये पावर दोनों 2 था और ये पावर 1 से स्टार्ट होकर के 0 तक जा रहा है. सेकेंड सब्स्टिट्यूशन में क्या हो रहा है? ये पावर 3 आ रहा है और ये पावर 3 आ रहा है और ये पावर 2 है, देन 1 है एंड देन 2 to the power 0 है. मीन्स यहां पर पावर 2 1 0 आ रहा है. ठीक है ना? इसी तरह से अगर हम लोग k माइनस 1 टाइम्स, देखिए 2 बार अगर सब्स्टिट्यूट कर रहे हैं तो ये 2 to the power 3 आ रहा है. अगर इसी तरह से हम लोग k माइनस 1 टाइम्स सब्स्टिट्यूट करेंगे, क्या करेंगे? सब्स्टिट्यूट करेंगे तो क्या रिजल्ट आएगा? जस्ट सी ओवर हियर. ठीक है ना? अगर k माइनस 1, देखिए 2 टाइम्स अगर कर रहे हैं तो ये 3 आ रहा है, तो k माइनस 1 टाइम्स करेंगे तो ये कितना आएगा? 2 to the power k t n by 2 to the power k, and this part will start from the k minus 1 and plus 2 to the power k minus 2 and plus up to dot dot dot, it will become 2 to the power 1 and 2 to the power 0. So finally we are getting this particular results. My dear friends, it requires some mathematical concept. To solve this kind of problem, it requires some mathematical concept which is very much easy. चलिए अब इस particular part को हम लोग solve करते हैं. I'm taking this into the new slide. Okay, I'm taking this into the new slide. See over here. Now, अब आप एक बात बताओ कि n को हम लोग क्या कर रहे हैं? बार बार 2 से डिवाइड कर रहे हैं. पहली बार 2 से डिवाइड करेंगे तो n by 2, दूसरी बार फिर से 2 से डिवाइड करेंगे तो n by 2 स्क्वायर, और इसी तरह से हम लोग डिवाइड करते जाएंगे तो ये n by 2 to the power कितना आ रहा है? k. कभी ना कभी ये वैल्यू कितना हो जाएगा? 1 हो जाएगा ना. लाइक टेक एग्जाम्पल, सपोज वी आर कंसिडरिंग द n इक्वल टू 16. 16 को आप 2 से डिवाइड करो, ये 8 होगा. 8 को फिर से 2 से डिवाइड करो तो ये कितना होगा? 4 होगा. 4 को फिर से 2 से डिवाइड करो, ये कितना होगा? 2 होगा. 2 को फिर से 2 से डिवाइड करो तो ये कितना हो जाएगा? 1. तो जब कभी भी किसी भी नंबर को बार बार 2 से डिवाइड करते हैं तो देयर विल बी अ टाइम व्हेन इट विल बिकम द 1. सो वी आर एज्यूमिंग आफ्टर k टाइम डिवाइडेशन. कितने टाइम डिवाइड करने के बाद? k टाइम्स डिवाइड करने के बाद ये वैल्यू कितना हो जा रहा है? 1 हो जा रहा है. ये वैल्यू कितना हो जा रहा है? 1 हो जा रहा है. तो यहां पर हम लोग क्या लिख सकते हैं? n is equal to 2 to the power k. If this is the things, then n will become 2 to the power k. Take log on both side. दोनों साइड log लेंगे तो log of n on the base 2 is equal to log of 2 to the power k on the base 2. So this implies k is equal to log of n. Means my dear friends, log n times divide अगर हम लोग करते हैं तो ये वैल्यू किसके इक्विवेलेंट हो जाएगा? 1 के इक्विवेलेंट. Are you getting my point or not? If you will divide the value n again and again by 2 up to the log of n times, it will become equivalent to, क्लियर? देखिए इसको और भी अच्छे से समझने का तरीका क्या होता है, देखिए अल्टीमेटली व्हाट वी आर गेटिंग n by 2 to the power k, value of k is log of n, so 2 to the power log of n, so what is the value of 2 to the power log of n, what is the value of 2 to the power log of n, see over here, 2 to the power log of n, suppose this is equivalent to p, take log on both side, दोनों साइड अगर हम लोग log लेंगे तो क्या होगा, log of n is equal to log of p, now remove log from both side, this implies p is equal to n, means whenever there is written 2 to the power log of n, this is equivalent to n, please remember this result, please remember this result, so 2 to the power log of n is equal to, so ultimately this can be written as n by n and this can be written as, clear? So just see over here, यहां पर देखो ये कितना आ जाएगा 2 to the power log of n and this implies n by 2 to the power k, so n by 2 to the power k, what we have imagined, we have assumed n by 2 to the power k is equal to 1, so we will consider it over here. Now just look upon this series, इस पर्टिकुलर सीरीज को आप देखो, भाई 2 से डिवाइड करोगे तो कभी ना कभी तो होना है ना, देखो if you are considering the 20, so divide it 10, 5, then 2 and then 1, yes or no? So again it will take approximately k times. Suresh, are you getting my point or not? Suresh, are you getting my point? So कभी ना कभी वैल्यू 1 होना ही है, ठीक है ना, so this will take k times and ultimately you are getting the value of k is equal to 1, sorry, value of k is equal to log of n, so just see over here, so इस सीरीज को आप अच्छे से देखो, ये किस तरह का सीरीज है, दिस इज द जीपी सीरीज, तो इस वाले पार्ट पे हम आते हैं, पहले इस वाले पार्ट को सॉल्व करते हैं, वी आर सॉल्विंग द लेफ्ट हैंड साइड, सो 2 to the power log of n, इट विल बिकम n, और इसका वैल्यू क्या होगा भाई, अगर आपने n को फिक्स कर दिया है तो इसका वैल्यू हमेशा कांस्टेंट होगा, सो इट विल बिकम ऑर्डर ऑफ n, so from this side, from this particular side we are getting the time complexity order of n. Now let's see what we are getting from this particular side, ठीक है ना, ये हमारा जीपी सीरीज है, पहले इसको सॉल्व करेंगे, then we will try to realize what is the complexity this part is deriving, okay, this part is deriving, see over here, देखिए अब सीरीज हमारे पास क्या है, 2 to the power k minus 1 plus 2 to the power k minus 2 and plus up to dot dot dot, this is the 2 to the power 1 and 2 to the power 0. Can we write the same series into this form, 2 to the power 0, 2 to the power 1 plus 2 to the power 2 and plus up to dot 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 plus 2 to the power k minus 1. Can we write? So again this is the GP series, और GP series का सम क्या होता है, अगर कहीं पर भी आप लोगों ने 11th 12th में पढ़ा होगा, फिर भी मैं रिपीट कर दे रहा हूं, देखिए ये सब इंपॉर्टेंट थिंग्स है जो आपको बहुत सारे न्यूमेरिकल्स में काम आएंगे, इसीलिए ध्यान से समझना, देखिए सम ऑफ जीपी सीरीज, सम ऑफ जीपी सीरीज होता है a इंटू r to the power n minus 1 divided by r minus 1 whenever value of r is greater than 1, and this is equivalent to a into 1 minus r to the power n divided by 1 minus r whenever value of r is less than 1. Now a is initial term over here, a जो है वो सीरीज का इनिशियल टर्म होता है, ठीक है ना, r is equal to रेशियो ऑफ टू consecutive terms, two consecutive terms and n is equal to number of terms. What is it? Number of terms. Clear? So r is the ratio of terms. So looking upon the ratio, we will think about which particular part will be applied, which particular formula will be applied. So if the ratio is greater than 1, then apply the first formula. If the ratio is less than 1, then apply the second formula. So I'm just saying it over here. It is the ratio of two consecutive terms. So my dear friends, can you tell me what is the ratio over here? इस पर्टिकुलर सीरीज में अगर आप देखो तो रेशियो हमारा क्या आ रहा है, दो कंसेक्यूटिव टर्म्स का 2 to the power 1 डिवाइडेड बाय 2 to the power 0. दिस इंप्लाइज 2 to the power 2 divided by 2 to the power 1. This implies 2 to the power 3 divided by 2 to the power 2. ये सभी consecutive terms हैं. And this is coming out to be 2 and 2 is greater than 1. Means the ratio is greater than 1 over here. So which formula we will apply? We will apply the first one. So यहाँ पर sum क्या आएगा? Sum will be the a into r to the power n minus 1 divided by r minus 1. So यहाँ पर initial term कौन सा है? This one is the initial term. So this one is the value a. And what is the total number of terms? See over here. We are starting from the 0 and we are moving to the k minus 1. So the value of n will become k. जो number of terms है वो कितने हो जाएंगे? k हो जाएंगे. क्योंकि अगर आप 0 to 9 जाते हो तो you are actually following the 10 steps. So the value of n will become k. So you can write 2 to the power 0, value of r is 2, so 2 to the power k minus 1 divided by again 2 minus 1. So this implies 2 to the power k minus 1. So this implies 2 to the power, what is the value of k? Log of n minus 1. And you know 2 to the power log of n is nothing but n. So n minus 1, and this implies order of. Got it? Order of n. So finally from this side again we are getting the order of n. So order of n plus order of n, it will derive the order of n. So ultimately t of n will become order of. Got it? So the problem which I have asked you previously, like the program was given and you have to find out the time complexity. The right time complexity of the same program will be order of n. Clear everyone? बात समझ में आ रहा है? Now let's come to the another break. Okay? Just see over. Now I'm assuming the second example, that is the example number C. Suppose the recurrence relation is given in this form. T of n is equal to 2t n by 2 and plus, अब यहां पर मैंने n रख दिया. तो चलिए फर्स्ट टाइम इस वाले पार्ट को हम लोग सब्स्टिट्यूट करेंगे तो क्या आएगा? जस्ट देखो यहां पर n के जगह हम लोग n by 2 प्लेस कर रहे हैं. तो n by is equal to 2t, just replace the value of instance of n by 2 divided by 2 plus this one will become n by 2. So ultimately this is the value we are getting. So replace this value in this place. So what will happen? T of n is equal to 2 inside the bracket 2t n by 2 square and plus n by 2, and outside the bracket there is a value n. Now multiply the 2 by each terms, so it will become 2 square t n by 2 square and plus 2 into n by 2, and this is the outside. So ultimately this one will be cancelled and it one will become 2 square t n by 2 square and plus 2. See, this result we are getting in first substitution. तो देखिए फर्स्ट सब्स्टिट्यूशन में क्या हो रहा है, इसका पावर भी 2 है, इसका पावर भी 2 है और यहां से भी 2 से मल्टीप्लाई हो रहा है. Similarly, if you will do the substitution second times, what will happen? आप कर करके देख लेना. It will become 2 to the power 3 t n by 2 to the power 3 n plus 3. This result you will get in second substitution. So देखिए, फर्स्ट सब्स्टिट्यूशन में ये पावर 2 आ रहा है, सेकंड सब्स्टिट्यूशन में 3 आ रहा है. तो इस तरह से अगर हम लोग k माइनस 1 टाइम्स सब्स्टिट्यूट करेंगे तो क्या आएगा भाई? इट विल बिकम 2 to the power k t n by 2 to the power k n plus k n. नाउ भाई अगर n को बार बार 2 से सब्स्टिट्यूट करेंगे तो कभी ना कभी ये वैल्यू 1 होगा. सी ओवर हियर, इफ n by 2 to the power k is equal to 1, so this implies k is equal to log of n. Already we have calculated. भाई दोनों तरफ log लेंगे, k का वैल्यू कितना हो जाएगा? Log of n. So here you can write 2 to the power log of n t of 1 and plus n. What is the value of k? This is the log of n. So this implies, what is the value of this? Already we have calculated this value. So the value of this is nothing but n. So you can write n over here into the value of this is nothing but c. This is the constant and plus this is the n log n. भाई इन दोनों में से बड़ा टर्म कौन है? This is the bigger term. So it will become order of n. So finally the complexity of this particular problem will become order of n. क्लियर एवरीवन? समझ में आ रहा है? बोलो भाई, इज इट क्लियर? सौरभ, सुरेश, एवरीवन. अब धीरे धीरे प्रॉब्लम के डिफिकल्टीज को हम लोग इंक्रीज करेंगे, तो जस्ट कीप सम पेशेंस. ओके फाइन, सी ओवर हियर. बहुत सारे न्यूमेरिकल को देखेंगे. नाउ लेट्स सी वन डिफरेंट न्यूमेरिकल. ओके, एग्जांपल नंबर 3. सी, if I am giving you t of n is equal to t root under n plus, okay, so you can write this into this form. t root under n का मतलब क्या होता है? n to the power 1 by 2 and plus 1 can be write in this form. ठीक है ना? तो अब यहां पर मुझे क्या करना है? we have to substitute the value of this. so अगर t of n ये है तो यहां पर अगर हम लोग n के जगह पे n to the power 1 by 2 प्लेस करेंगे, क्या आएगा? t n के जगह में प्लेस कर रहे हैं 1 by 2. सो यहां पर ये आएगा. तो यहां पर क्या लिख सकते हैं? t रूट अंडर n के जगह में 1 by 2 मैंने प्लेस कर दिया प्लस 1. सो व्हाट इट विल बिकम? t रूट अंडर दिस. तो n to the power 1 by 2 तो है ही, और रूट का मतलब होता है अगेन 1 by 2 प्लस 1. सो दिस वन विल बिकम t n to the power 1 by 2 square plus 1. Any confusion? Now what we can write? Whenever you will substitute this, you will substitute this by this. So it will become t of n to the power 1 by 2 square plus 1. This is the substituted value and this is the plus 1. So ultimately it will become t of n to the power 1 by 2 square and plus 2. क्लियर एवरीवन? तो देखिए फर्स्ट टाइम हम लोग सब्स्टिट्यूट कर रहे हैं तो यहां पर ये स्क्वायर आ रहा है, ठीक है ना? दूसरी बार ये तो पहले सब्स्टिट्यूशन में आ रहा है. वी आर गेटिंग दिस इन द फर्स्ट सब्स्टिट्यूशन. सेकेंड टाइम सब्स्टिट्यूट करेंगे तो क्या आएगा? t of n to the power 1 by 2 to the power 3 plus 3. Yes or no? This we will get in the second substitution. तो देखिए दूसरी बार सब्स्टिट्यूट कर रहे हैं तो ये पावर भी 3 आ रहा है और यहां पर भी 3 आ रहा है. सिमिलरली अगर k माइनस 1 टाइम्स सब्स्टिट्यूट करेंगे, what we will get? we will get the t to the power t into t of n to the power 1 by 2 to the power k and plus k। तो देखिए किसी भी नंबर का बार बार रूट लेते रहो, ठीक है ना। किसी भी नंबर x का अगर हम लोग बार बार रूट करते रहेंगे, फिर से रूट कर रहे हैं, ओके, रूट ऑफ x, अगेन हम लोग इस नंबर का रूट कर रहे हैं, रूट ऑफ x, अगेन रूट ऑफ x, अगेन रूट ऑफ x, सो अप टू डॉट डॉट डॉट। कभी ना कभी ये वैल्यू 2 तो हो जाएगा ना। देयर विल बी अ सिचुएशन if you are taking the root value of something again and again, sometime it will reaches to 2, yes or no, all of you, kabhi na kabhi ye value 2 ho jayega। if you are repeating the root again and again, either it will become 2 or less than equal to 2, means either you can write 2 or it will become less than equal to 2, okay fine। so just imagine if n to the power 1 बाई, भाई यहां पर कितने टाइम्स हम लोगों ने रूट लिया है, इस तरह से डॉट 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 कितने टाइम्स लिया है के। तो अगर ये वैल्यू 2 होता है, नाउ टेक लॉग ऑन बोथ साइड, दोनों साइड आप लॉग ले लो, तो क्या होगा, लॉग ऑफ n टू द पावर 1 बाई 2 टू द पावर k इज इक्वल टू log of 2 on the base 2 and this one implies 1। so इसका log लेंगे, क्या होगा, आपको थोड़ा सा तो log का प्रॉपर्टी पता होगा, 2 to the power log of k into log of n is equal to 1 and this implies, इसको राइट हैंड साइड पे मल्टीप्लाई करिए, तो log of n is equal to 2 to the power k। now again take log on both side, तो यहाँ पर क्या हो जाएगा, log n is equal to k। so ultimately the value of k will become log n। got it? so what we can write over here, इस वैल्यू को हम लोगों ने कितना एज्यूम किया है, what we have assumed in place of this particular value 2। तो अगर मैंने इसको 2 एज्यूम किया है, तो वैल्यू ऑफ k is coming out to be log n। so of course this one will become constant and this one is the log n। so ultimately this one will become log। got it? so ultimately we are getting the t of n is equal to order of log। कोई दिक्कत? if you are getting any doubts anywhere, you can ask me, all of you। Saurabh, are you there? all of you, if you are facing any problem anywhere, you can ask me freely, okay fine। so this is how we basically solve the numerical। now I'm just telling you some of the results because later on I'm going to use all those results, just see over here, ठीक है ना। some important results, सी पहला क्या है, ठीक है ना। सबका हम लोग एक लॉजिकल प्रूफ भी देखेंगे, वी विल सी द लॉजिकल प्रूफ फॉर ईच एंड एवरी सीरीज। सी ओवर हियर, whenever it is given 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus dot 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 1 by n, so this is not equal to, you cannot write the equal to, but this is equivalent to log of n on the base 2। देखिए इक्विवेलेंट और इक्वल में अंतर होता है। इक्विवेलेंट मीन्स सपोज आपके पास 1,01,000 रुपया है, तो आप बोल सकते हो कि भाई मेरे पास 1,00,000 रुपया है। यू विल नेवर से टू एनीवन कि मेरे पास भाई 1,01,000 है। सो दैट्स व्हाई योर अमाउंट कैन बी इक्वेटेड इन द फॉर्म ऑफ 1 लाख। या आपके पास 99,000 है, तो भी आप बोल सकते हो कि भाई मैं लखपति हूं, ठीक है ना। अगर किसी के पास मान लो 99 लाख है, तो वो अपने आप को करोड़पति ही बोलेगा, वो कभी भी अपने आप को लखपति नहीं बोलेगा। या सपोज किसी के पास लाइक 99,90,000 है तो भी वो अपने आप को करोड़पति बोलेगा। ये नहीं बोलेगा कि भाई मेरे पास 10,000 कम है तो मैं लखपति हूं, नॉट अ करोड़पति। आर यू गेटिंग माय पॉइंट और नॉट? दैट इज द मीनिंग ऑफ इक्विवेलेंट। मीन्स इन कॉम्प्लेक्सिटी थ्योरी वी ऑलवेज ट्राई टू अप्रोक्सीमेट द वैल्यू, वी विल नेवर गेट द एग्जैक्ट वैल्यू। हम लोग कभी भी एग्जैक्ट वैल्यू या एग्जैक्ट टाइम का कैलकुलेशन नहीं कर पाते। फॉर मोस्ट ऑफ द प्रॉब्लम, 90% प्रॉब्लम के लिए हम लोग कभी भी एग्जैक्ट कैलकुलेशन नहीं कर पाते हैं। इन दैट सिचुएशन व्हाट वी विल डू सम अप्रोक्सीमेशन। अगर सपोज किसी भी प्रॉब्लम का, किसी भी प्रोग्राम का एग्जीक्यूशन टाइम 100 मिली सेकेंड्स है, ठीक है ना, आपने कैलकुलेट किया 100 मिली सेकेंड, तो एक्चुअल जो टाइम होगा जब आप इसको कंप्यूटर पे रन करोगे, सपोज बाय theoretically you have find out the execution of time of your program is 100 millisecond, but practically जब हम लोग इसको implement करेंगे then either we can get 98.9 millisecond or we can get 101 millisecond. We cannot get the exact value. So practical और theoretical में कुछ अंतर होते हैं, and that's why we always try to approximate the value. Now let's see why I am writing the sum of this series is equal to log of n, where यहां पर ये जो n है ये क्या है? This is the number of terms, number of terms. So 1 से लेकर के अगर आप n terms तक जाते हो डिवाइड के फॉर्म में, तो it will be equivalent to the log of n. See over here, I'm just giving you a logical proof. I'm just giving you a logical proof. Suppose if n is equal to 4, n is equal to 4. So my dear friends, अगर n is equal to 4 होता है तो from the left hand side, left hand side में क्या है? ये है, तो number n is equal to 4 means number of terms should be 4. So just write it over here, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. तो भाई यहां पर नंबर ऑफ टर्म्स कितने हैं? 4 है। नंबर ऑफ टर्म्स इज इक्वल टू 4। अब इन सब का सम सीरीज क्या है? देखिए 1 प्लस 1 बाई 2 का मतलब होता है 0.5, 1 बाई 3 का मतलब होता है 0.33, 1 बाई 4 का मतलब होता है 0.25। टेक द सम वैल्यू। इसका सम वैल्यू कितना हो जाएगा? इट विल बिकम 2.08। यस और नो? इसका सम वैल्यू कितना आ रहा है? 2.08। एंड फ्रॉम द राइट हैंड साइड सम वैल्यू कितना आ रहा है? log of n on the base 2. So here we have assumed the value of n is equal to 4. So 4 on the base 2. So this is equal to, now just equate the left hand side value and the right hand side value. Both are approximately equivalent. So saying the sum of this particular series equivalent to the log of n is the correct statement. Are you getting my point or not? Is the correct statement. कोई confusion? बोलो भाई। So applying the same concept, I am writing the another series. Suppose the series is given like this: 1 plus 1 by 1 plus 1 by 2 plus 1 by 3 plus up to ... plus 1 by log of n. So my dear friends, in this sum series the number of terms is how much? यहां पर number of terms कितने हैं? log n है। तो सम, किसी भी सीरीज का सम क्या होता है? अगर n टर्म्स है तो इट विल बिकम log of n, और अगर n के जगह ही मैंने नंबर ऑफ टर्म्स log n ले लिया तो ये कितना हो जाएगा? log of n. Of course this particular part always define the number of terms. So this is nothing but the number of terms. तो जो भी नंबर ऑफ टर्म्स आ रहे हैं उसके आगे log ले लेना है। तो इस सीरीज का सम हमारा क्या होगा? Is it clear? All of you? So just see the one another example. अब एक एग्जाम्पल देखते हैं। Suppose this is the example number This is the example number 3. Suppose the recurrence relation is given in this form. T of n is equal to T n minus 1 and plus 1 by n. And they are asking find T of. तो चलिए इसको सॉल्व करते हैं. अब आपको आइडिया हो गया होगा कि इस तरह के रेक्टेंस रिलेशन का सम वैल्यू क्या होगा. सी, अगर पहली बार इसको सब्स्टिट्यूट करेंगे, देखिए यहां से देखिए, अब यहां पर हम लोग क्या कर रहे हैं, n के जगह हम लोग क्या प्लेस कर रहे हैं, n माइनस 1. सो वेन एवर यू विल प्लेस n माइनस 1 इन प्लेस ऑफ n, दिस इंप्लाइज, अब यहां पर n के जगह n माइनस 1 पुट करिए, ये कितना हो जाएगा, n माइनस 2, एंड यहां पर n के जगह भी n माइनस 1 आएगा, तो इट विल बिकम 1 बाई n माइनस 1. तो जस्ट सब्स्टिट्यूट दिस, इसके वैल्यू को सब्स्टिट्यूट करिए, तो इट विल बिकम t ऑफ n माइनस 2 प्लस 1 बाई n माइनस 1, ये तो सब्स्टिट्यूटेड वैल्यू है, एंड आउटसाइड ऑफ दिस देयर इज 1 बाई, ठीक है ना. तो ये हम लोग को मिल रहा है इन फर्स्ट सब्स्टिट्यूशन. वी आर गेटिंग दिस इन फर्स्ट सब्स्टिट्यूशन. सिमिलरली सेकंड सब्स्टिट्यूशन में, मतलब फर्स्ट सब्स्टिट्यूशन में हमारा क्या आ रहा है, टी एन माइनस 2 प्लस 1 बाई एन माइनस 1 प्लस 1 बाई एन. सिमिलरली सेकंड सब्स्टिट्यूशन में क्या आएगा, टी ऑफ एन माइनस 3 and plus 1 by n minus 2 and plus 1 by n minus 1 and plus 1 by n. इसी तरह से अगर हम लोग n minus 1 टाइम्स सब्स्टिट्यूट करेंगे तो इट विल बिकम t of 0 plus 1 plus 1 by 2 plus 1 by 3 plus up to dot 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 1 by n minus 1 and plus 1 by, yes or no, all of you, will we get this particular series or not? So here of course the value of this is constant, and sum of this series will become log n. So ultimately this is what we are trying to calculate. So this implies t of n is equal to order of log. Clear? This one will become the final answer for the above recurrence relation. Clear है भाई? Now I am giving you a question and giving you a time of 2 minutes. See over here. T of n is equal to 2t root under n plus, and I am asking find t of. So my dear friends, this is the question of GATE 2008. So take your time. I am giving you a time of 2 minutes. You take your time and tell me the answer. Any answer? All of you. If you are getting any answer, then tell me. See, I'm giving you the option. Okay? If you want, I'm giving you an option. Order of log n p. Order of root under n c. Order of log n and d. Order of, okay, I have given you the 4 options and you have to choose the right option over here. Let's see the solution. Okay, let's see the solution. See over here. See what is given inside the question. देखिए इस तरह का क्वेश्चन अभी हम लोगों ने जस्ट किया था, बस वहां पर ये 2 नहीं था, अब मैंने 2 इंट्रोड्यूस कर दिया है. T of n is equal to 2t root under n plus 1. ओके, नाउ पहली बार इसको सब्स्टिट्यूट करेंगे. पहली बार क्या कर रहे हैं हम लोग, इस पर्टिकुलर पार्ट को सब्स्टिट्यूट कर रहे हैं. सो व्हाट वी विल गेट, वी विल गेट 2t n to the power 1 by 2 square plus 1, और ये बाहर में आउटसाइड प्लस 1 है, ठीक है ना. नाउ मल्टीप्लाई इट, सो इट विल हैपन 2 square t n to the power 1 by 2 square plus 2 and plus. So this result we are getting in the first substitution. Second, in the second substitution, similarly what we will get, 2 to the power 3 t n to the power 1 by 2 to the power 3 and plus 2 square plus 2 and plus 1. This result we will get in the second substitution. Similarly, my dear friends, second substitution में ये power 3 है, ये भी power 3 है, and the remaining power is starting from the 2, 1 and this is nothing but 2 to the power 0. So if you will substitute k minus 1 times, k minus 1 times, what will happen, it will become 2 to the power k t n to the power 1 by 2 to the power k and plus this one will become k to the power 2 to the power k minus 1 plus 2 to the power k minus 2 and plus up to dot 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 up to dot 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 2 to the power. Saurabh, please try to understand. Okay, here it will get 2 to the power 1 and 2 to the power 0. So already I have told you, if n to the power 1 by 2 to the power k is equal to, we are assuming 2. We are assuming because once you will take the root of any number again and again, sometime it will become 2. So here the value of k coming out to be log n. Yes or no? Already in the previous numerical I have told you how to calculate this. This is very simple. Okay, so you can take the log on both sides 2 times, then you will get this result. So here it will become 2 to the power log n t of 2 and plus this one is the GP series, and already I have solved. What is the sum of this GP series? The sum of this series is 2 to the power k minus 1. So you can write 2 to the power k minus 1 over here. Now let's see. Let's see. So ultimately t of n is equal to 2 to the power log n t of 2 and plus 2 to the power log n minus 1. So my dear friends, 2 to the power log n, this is equivalent to the log of n. Yes or no? Just apply the logarithmic property. Take the log on both sides and then you just find out the answer. So this is nothing but log of n. T of 2 value is constant, and again this is the log of n minus 1. So it one will become order of log of. Got it? So the right answer of these questions will become the C. Clear everyone? Saurabh and Suresh, समझ में आया? So without 2 you are getting the log n. If there is a 2 then you will get log n. Is it clear to all of you? Chaliye. Now let's see one more numerical. Let's see one more numerical. But before solving the numerical, let's try to see some important result. Okay. Important result, because in the next numerical I am going to use this result. Important result. See over here, you know about this. If there is given n into n minus 1, what is the upper bound of this? You can write n square, means if the function of f of n is coming out to be this, then upper bound of this is n square. If the function is given as n into n minus 1, n minus 2, what you will write? You will write order of n q. Similarly, if someone is writing n into n minus 1, n minus 2, n minus 3 up to dot 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 n minus 1. So what you can write? You can write order of n to the power n. Yes or no? You can write order of n to the power n. So what you are doing, you are multiplying the n into n times. So while finding out the time complexity, we always ignore the lower degree term and the constant term. I hope you know about this. While finding out the time complexity, we always ignore the lower degree terms and the constant term, and that's why this is coming out to be this. And you also know what is this. So this is nothing but factorial of n. So the upper bound of factorial n is nothing but n to the power n. The upper bound of factorial n is n to the power. So this is one of the important result that you have to keep in your mind. Clear everyone? Now I am giving you an example related with the same concept. Just see over here. See, this is the example number 5. All the examples which I am talking in my lectures, mostly examples indirectly already came into your GATE exam. See, suppose the recurrence relation is given like this: t of n is equal to t n minus 1 and plus log of n. And what they are asking the find the t of n. Just see over here. See, this is the recursive call. So first of all we will substitute this value. So in place of n if you will place the n minus 1, what value you will get? We are placing the n minus 1, so you will get t n minus 2 and plus log. Every instance of a will be substituted by the n minus 1. So this value we are getting. Now we will substitute this value. We will substitute this value over here. So what will be the actual recurrence relation? T of n will become t n minus 2 and plus log of n minus 1 and plus log of. So this result we are getting in the first substitution. The first substitution. Now in the second substitution, what you will get? T n minus 3 plus log of n minus 2 plus log of n minus 1 and plus log of n. So similarly, if you will substitute n minus 1 times, what you will get? You will get the t of 0 plus log of 1 plus log of 2 plus up to dot 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 log of n minus 1 plus log of. So you know the properties of the log. Log of a on the base 2 plus log of b on the base 2. If the base is same, then this one will become log of a into b on the base 2. So applying the same concept, of course this value is constant. So here it will become log of n into n minus 1 into n minus 2 into up to dot dot dot. Either you can write 1 or you can write n minus 1. Yes or no? Either you can write 1 or you can write n minus 1. So ultimately what you can write? C plus log of. Of course this is the factorial. This is nothing but a factorial. So this is nothing but a factorial. So what is the upper bound of the factorial? This is the n to the power n. So you can write c plus n log n, and ultimately you can write order of n. So finally, what will be the final solution of this recurrence relation? Order of n. Clear everyone? Is this particular concept clear or not? Now let's come to the another numerical. Now I am giving you an interesting numerical. See, this is the numerical of MSQ type. MSQ type. MSQ means multi-select question, and I am asking which of the following options is are which of the following options is are true. The first one is given as summation over I is equal to 0 to log of n 1 by 2 to the power I is equal to order of log of. Option B is summation over I is equal to 1 to log of n 1 by I is equal to order of log n. C is summation over I is equal to n to 1 to n and log of, this is the n minus 1, log of n minus I is equal to order of n. Option D is given as summation over I is equal to 1 to n I square is equal to order of square. Just tell me the answer, guys. Just tell me the answer. All of you, I'm giving you a time of 2 minutes. Giving you a time of 2. Take your time and tell me the answer. Take your time and tell me the answer. This is the MSQ type questions where more than one options could be true. ठीक है ना? और MSQ टाइप क्वेश्चंस का क्या पैटर्न है? इफ you are marking only one true options and you are not able to identify the second true options, then your final marks will be evaluated as 0. ठीक है ना? पार्शियल इसमें आपको मार्किंग नहीं मिलने वाला. If you are correcting all the means, if you are picking all the true options, then only you will get the answer. और अगर सपोज इसमें 2 ऑप्शन ट्रू है और आपने 3 को मार्क कर दिया, तो इन दैट सिचुएशन ऑल्सो यू विल बी असाइंड अ 0 मार्क्स. ठीक है ना? तो आपने सही किया है, गलत को कर दिया तो आपको फिर से 0 मार्क्स मिलने वाले. सो टेक योर टाइम एंड टेल मी द आंसर. All of you, take your time and tell me the answer. Deepika, you can check your internet connection. Deepika, you can check your internet connection. Okay. Now, just see the explanation. Just see the explanation. Okay. The first part is saying, starting from I is equal to 0, we are moving to the log of n, and this is the summation series. 1 by 2 to the power I is equal to this. Let's see whether it is true or not. See, summation over I is equal to 0 to log of n 1 by 2 to the power I. So what it will become? 1 by 2 to the power 0 plus 1 by 2 to the power 1 plus 1 by 2 to the power 2 and plus up to dot dot dot. How many times it will move? It will move up to the log of n times. Clear, everyone? Now again you can realize this is the GP series. This is the GP सीरीज, और इस GP सीरीज में जो रेशियो है कंजुकेटिव टर्म्स का, लाइक 1 by 2 to the power 1 divided by 1 by 2 to the power 0. This is equivalent to 1 by 2 square divided by 1 by 2. This is equivalent to, ये कितना आ रहा है, 1 by 2. So the ratio is less than, one. Here we are getting the ratio less than 1. So my dear friends, if the ratio is less than 1, what is the sum of GP series? Already I have told you, A into 1 minus R to the power n divided by 1 minus R. So in this situation, in the above series, value of A is equal to 1 by 2 to the power 0, which is nothing but 1. The value of R is equal to 1 by 2. And what is the total number of terms? We are starting from the 0 and we are moving to the log of n. We are starting from the 0 and we are moving to the log of n. So the total number of terms n will become log of n plus. So just replace it over here. So it will become 1 into 1 minus R, that means 1 by 2 to the power log of n plus 1, okay, divided by 1 minus 1 by 2. So ultimately it will become half. So 2 will come upper side. 1 minus, we can write 1 by 2 to the power log of n plus 1. So we can write 2 minus 2 into 1 by 2 to the power log of n into 2. This 2 will be cancelled out. So 2 minus 1 by n, isn't it? 2 minus 1 by n. So this is the things we are getting in the summation over I is equal to 0 to log of n 1 by 2 to the power. So my dear friends, the complexity is always calculated for the higher value of n. So if n is very high, then 1 by n will tending to 0. Means for the large value of n, it will become 2, which is nothing but order of 1. That is the, which is nothing become order of 1. So that is the constant. So ultimately what we are getting, the summation over I is equal to 0 to log of n 1 by 2 to the power I is equal to order of, So this is also a important result. Please keep this in your mind. Okay. So saying summation over this is just a false statement. Now you know about this. That the summation over I is equal to 1 to log of n, it is given as 1 by I. So of course it will become 1 plus 1 by 2 plus up to dot 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 1 by log of n. So summation over this is, already I have told you, this is the log. So this particular statement is true. Those who have joined new, okay, you can watch my previous lectures. Already I have given the explanation of this. How it is coming out. Log n. Okay, so this is the true statement. Now just see this particular statement. What this particular statement says, summation over I is equal to 1 to n minus 1 log of n minus I. This is nothing but what will happen over here. So if the value of I is equal to 1, so it will become n minus 1 plus log of n minus 2 and plus up to dot 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 plus log of, so what you can write, log of n minus 1, n minus 2 and dot 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 1. So this is nothing but a factorial n. So you can write log of factorial n, and what is the upper bound of factorial n? So n to the power n. So you can write n. So finally, saying the statement, the upper bound of this is this. This is the true statement. Now let's analyze the option D. So my dear friends, already you know about the option D. Summation over I is equal to 1 to n I square. This implies 1 square, 2 square plus up to dot 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 n square. What is the sum of this series? So sum of this series is n into n plus 1 into 2n plus 1 divided by 6. So this one will become order of n. So saying the statement, this is the n square, this is absolutely. So the right answer of these questions will be B comma C. The right answer of these questions will be B comma C. Is that clear? All of you? Deepika? Okay. The right answer of this question will become the B comma C. So this is one of the predictable questions which can be asked in your MSQ type questions. Which can be asked in your MSQ type questions. My dear friends, already you know there are 3 different series which you have to remember. This one is the first. The second already you know, the summation over I is equal to 1 to n I. This is nothing but order of n square. Okay. The third one is summation over I is equal to 1 to n. This is the constant is equal to order of n. The fourth one is summation over I is equal to 1 to n, and this is the I to the power 3 is equal to order of n to the power Of course there is a short form also, but for that you have to keep the patience, Deepika. There is a short technique also, but for that reason, see, the short techniques require 2 different things. One is the practice, one is the remembering some results. Okay, now let's come to the another numerical. Now my dear friends, to move on into the new numericals, let's learn something. Okay, asymptotic notation. Okay, to represent the time complexity, we basically use 3 different kind of notation. Already you know about this. I will just discuss some of the thing about the notation so that we will be able to solve some of the standard numerical of the gate. See, the first one is BIGO, that is represented by this. Till now we have used only the BIGO. Second one is theta, that will be represented by this, and last one is omega, that will be represented by this. Now let's try to learn each and everything one by one. So first of all we are trying to learning the BIGO. So just try to think what is the meaning of BIGO notation. Suppose if I am writing f of n is equal to order of g of. So here we will say g of n is the upper bound of f of n. Here we will say g of n is the, we are including one term, tightest upper bound of f of n. And how you will represent the same syntax mathematically? See over here. Since g of n is the upper bound of f of n, so c into g of n will be greater than equal to f of n, and this one is greater than 0. So this is the mathematical representation of this particular statement. If I am saying g of n is the upper bound of f of n, or the tightest upper bound of f of n, it means c into gn is greater than equal to f of n. So once you will try to indicate the same thing by graph. So this is the value n is the input size, and this part is representing rate of growth. Just see over here. So this is the f of n, and this is the c into g of n. So this is the midpoint. This is the point where both are meeting. So for the particular value n naught, means after the particular value n naught, the rate of growth of, see over here, the rate of growth of c into g of n is higher than rate of growth of f of n. So this is applicable for all constant c and n naught, where n is greater than equal to, clear, where n is greater than equal to n naught. So this is the first thing about the big O notation. Now let's try to understand. You just remember the mathematical notation. Let's see the theta notation or omega notation. Omega. Just see. See, whenever I am saying g of n is the tightest lower bound of f of n. Here we will say g of n is the tightest lower bound of f of n. I am not writing the everything. You just listen very carefully. G of n is the tightest lower bound of f of n, and how you will represent mathematically, of course, the rate of growth of c into gn is less than f of n, and this one is greater than equal to 0. If g of n is the lower bound of f of n, then the rate of growth of g of n should be less than equal to f of n. And how you will represent the same thing mathematically or by the graph? Okay, so this is the f of n, and this is the c into g of n, and this is the input, and this is the meeting point, after which the rate of growth of f of n is greater than c into g of n. Now let's see the theta. Once I will take the example, you will be able to understand each and everything. So just wait. Let me explain each and everything. Now I am writing that g of n is the theta bound, or you can say the tightest bound of f of n. Here I am saying g of n is the tightest or the theta bound of f of n. So what does it mean? That sometime g of n will become greater than f of n for the constant c1, and sometime g of n will become lower than f of n for the constant c2, and this is greater than equal to 0. This is greater than equal to 0. Okay. So for the different value of C1 and C2, sometime g of n is becoming the upper bound of this and sometime it is becoming the lower bound of this. Means if both the condition big O and omega is satisfying for the same two function, then there exists the theta bound. Got it, everyone? Now, if you are getting this particular point, I am giving you one numerical of GATE 2012. Okay? Again, I will tell you, remember the mathematical result. Remember the mathematical result. See, I am giving you a question of GATE 2012. See, it is given as T of n is equal to 2t n by 2 plus then which one of the following option is correct about T of n. T of C. Option A is given as T of n is equal to order of, sorry, here it is asking not correct. Okay, it is asking not correct. Option B is given as T of n is equal to omega of n log n. Option C, T of n is equal to omega of n square. Option D, T of n is equal to theta of n. Tell me the answer, guys. Tell me the answer. I am giving you a time span of 2 minutes. Just think about it and tell me the answer. From this question, you will get the idea about the big O, omega, and theta notation. Take your time, not a problem at all. Okay. Any answer? Any answer? All of you. Okay. Very good. Deepika. Okay. See, my dear friends, what is the approach to solve this kind of problem? Please try to understand. Very good, Suresh. See, already we know how to solve this kind of recurrence relation. How to solve this kind of recurrence relation. So by the substitution method, whenever you will try to solve this recurrence relation t of n, you will get n log n. Yes or no? So of course t of n is the function. So this is the function f of n whose actual value is coming out to be this. Now let's try to verify each and every option. Suppose I am verifying the option A. So it is given as t of n is equal to order of n square. So t of n is nothing but the f of n is equal to order of this one is nothing but the g of n. So the value of g of n is equal to n square given inside the option. So whenever you are writing this statement, what does it mean? It means the g of n is greater, c into g of n is greater than equal to this. So just write it over here. What is the value of f of n? This one. So n log n is less than equal to c into n square. So my dear friend, this condition is true. This condition is true. Got it? For every value of n, this condition is true. So this is the correct statement. Again, this condition will become also true. But let's try to see the option C. In option C, it is given as t of n is equal to omega of n square. So this is nothing but the function f of n is equal to omega of, this is nothing but the g of n, where g of n is equal to n square. So how to represent the same thing mathematically? So this is the c into g of n less than equal to f of n. So c into n square less than equal to, what is the value of f of n? N log n. So this is not true for all n. किसी भी n वैल्यू के लिए ये स्टेटमेंट कभी भी ट्रू नहीं हो सकता. वॉट एवर द कांस्टेंट वैल्यू c you are assuming at particular moment, it will remains false. So this is the false statement. So ultimately this one will become our final answer, क्योंकि ये सभी ट्रू स्टेटमेंट है. ऑल दीज आर द ट्रू स्टेटमेंट. ठीक है ना? लेकिन ये हमारा गॉट इट. Now let's see the another problem, okay, which is the problem of GATE 2040. GATE 2000. Okay, very good, Deepika. GATE 2014. See, there are two functions given. F of n is equal to n and g of n is equal to n to the power 1 plus sine n. And there are two statements given. Statement 1 is f of n is equal to big O of g of n. The second statement is given g of n is equal to big O of f of, and which is option A is given as 1 only, option B is given as 2 only, option C is given as both, option D is given as none. This is the quite interesting problem. This is the quite interesting problem. Just tell me the answer, all of you. Just tell me the answer. Whatever the answer you people getting, just tell me the answer. I am giving you a time of 2 minutes. Think about this and tell me the. Suresh, Deepika, and Saurabh. Okay. Any other answer? Any other answer? If you are getting, you can share with me. See, my dear friends, see, we know the value of sine of n lies between -1 to 1 for all n. Yes or no? Suresh and Deepika, please try to understand. Already you know about the sine theta. The value of sine theta, or in place of theta we have considered the n, always lies between 1 and n. Like n का वैल्यू, अगर आप ये ग्राफ देखोगे तो of course this is the n part and this is the rate of growth. This is the rate of growth. So since the value of n is lying between -1 to n, means sometime this value will become either n square or it will become 1. Sorry, it will become 1. Yes or no? Either it will become n square or it will become 1. So as soon as you are increasing the value of n, sometime it is becoming the n square, sometime it is becoming the 1. Sometime it is becoming the n square, sometime it is becoming the 1. Are you getting my point or not? All of you. See over here, you know about this. Deepika, the value of sine theta lies between -1 to 1. This is the basic mathematics. So whenever value of sine theta is lies means for all value of n, the value of sine theta is like between -1 to 1 because it moves in a rotation form. So you are starting from the 0, you are going to the 90, then we are going to the 180. Of course we know sine 90 is equal to 1, but sine 180 is equal to 0. So I hope you know about this. So as soon as you are increasing the value in a cycle, the value of sine theta always moves between -1 to 1. So see, if the value of sine n is equal to, -1, see you in the next slide. If sine n is equal to -1, then n to the power 1 plus sine n will become n to the power 1 minus 1 will become n to the power 0 is equal to 1. But if the value of sine n will become 1, then n to the power 1 plus sine n will become n square. Means the function g of n, the value of function g of n lies between 1 to n square. It is never fixed. It is never fixed. Got it? It is never fixed. It always lies between 1 to n square, 1 to n square for all n greater than 0. So if such thing is happening, can you claim that the g of n is the upper bound of f of n? Because you can claim this whenever the f of g of n is always greater than equal to f of n. But this condition is sometime true and sometime false. So we are not able to decide whether the g of n is greater than f of n. So this is the false statement. Similarly, if I am talking about the g of n ka upper bound f of n hai, so this is also not possible, because sometimes g of n is coming out to be n square, sometimes it is coming out to be 1. So if it is n square, then means if it is n square, the condition is false, but if it is n 1, then the condition is true. So this statement is also false. So the right answer will be none of these. Clear, everyone? So the right answer will be none of these. Bolo bhai. And once you will merge the graph of this and this, how it will look like? It will look like this. This is the graph of f of n, linear graph, and this is the graph of g of n. So this is the graph of g of n. So just see over here. Sometime the value of g of n is greater than this, and sometime the value of g of n is less than this. So once you will merge the graph of f of n and g of n, the graph will look like this. So at the certain point, you are not able to claim which one is the upper bound of which function. Clear, everyone? So in this manner, you can easily think about the each and every numericals. Now, let's see the another numerical. My dear friends, this is the one of the unique numerical I am giving you. Okay, see, I am giving you a two different function, and these are the predictable questions. Predictable questions. Suppose f of n is given as f of n is given as n to the power 2.3. Okay, and g of n is given as, or you can just take the simplest example, not a problem at all. Okay, n to the power root under n, and this is the n to the power log of n, and two statement is given. F of n is the upper bound of g of n is the upper bound of f of n, and g of n is equal to ego of. Okay, again the same option, 1 only b, 2 only c, 3 only and d, sorry, both and. Okay, and next example I am giving you like this, example number 7. Okay, I am giving you two different recurrence relation, t of n is equal to 5t n by 2 plus n square. Okay, and f of n is equal to 4t n by 2. Sorry, this is not a t, this is the f. Okay, this is not a t, this is the f plus n square. And I am writing two different statements. T of n is equal to ego of this. Second statement is f of n is equal to ego of T of. Again, option is given as 1 only B, 2 only C, both and D. These are the predictable questions. Please try to identify the answer. I am giving you a time of 2 minutes for both the questions. See, what is the approach for finding out the solution of this kind of problem? Let me tell you the approach. Okay. Approach of comparing two different functions. See, only one approach is there. Okay, always think the value of function, for higher value of n, input size, which is nothing but. So this is the approach to solve any numerical. Whenever you are comparing two different functions, always follow this particular approach. Always try to compare two different functions for the higher value of n. So just see over here. Function f of n is taken as this and g of n is taken as this. See. Suppose n is equal to 2 to the power 64. N is equal to 2 to the power 64. Then what the function f of n will derive? N to the power root under n. So it will derive 2 to the power 64 to the power root under 2 to the power 64. So of course you can write 2 to the power 64 into, here you can write 2 to the power 32 into 2 to the power 32. So ultimately you can write 2 to the power 64 into 2 to the power 32. So ultimately you can write 2 to the power 64. 64 means 2 to the power 6 into 2 to the power 32. So ultimately it will become 2 to the power 48. Okay. Yes, Deepika, you can follow me over there, Ajay Das, and you will be able to realize. Okay. See. So this value we are getting for the function f of n whenever we have assumed the value n is equal to this. Similarly, let's calculate the g of n. g of n is equal to given as n to the power log of n. Just replace the value. 2 to the power 64, we have assumed the value of n. So here log of again 2 to the power 64. So it will become 2 to the power 64 into 64. So this will become 2 to the power 12. Okay, so this value we are getting 2 to the power 12. Now looking upon the value of function f of n and g of n, what we are realizing that the g of n is far smaller than f of n. So which one will become the upper bound? Which one will become the upper bound, my dear friends? Of course, this function will become the upper bound of this. Means the upper bound of g of n could be f of n. But if someone will say that upper bound of f of n is equal to g of n, then this is not correct. This is true, but this is not correct. So the right answer will become, yes, YouTube में तो मैं लेता ही हूं और प्लस वहां पर भी लेता हूं, स्पेशल क्लास में भी. Suresh, got it? This answer is clear to all of you. Looking upon these derivations, this answer is clear. So always remember these kind of things. Whenever you are trying to compare two different functions, then always think about the higher value of input size, that is the value of n. Clear? Now to solve, this is the one of the interesting problem, and this is the predictable problem. You are not going to get anywhere in the question bank. Okay, this is the problem created by me. So to solve this kind of problem, you have to solve this recurrence relation first of all. So my dear friends, either you can apply the substitution method, or to solve this recurrence relation you can apply the master theorem. What you can apply? You can apply the master theorem. See over here, using the substitution method is just a complex approach. Fine, and that's why we will follow the master theorem. So in the short form, I will explain the master theorem to all of you. This is the very easiest method. I will explain the master theorem all of you in a short form, and then I will come back to this numerical. Clear everyone? Now let's see the master. देखिए, मैं पढ़ाना तो बहुत कुछ चाहता हूं, मैंने एक्चुअली में बहुत सारे न्यूमेरिकल कंसीडर किए रखे हैं, ठीक है ना, लेकिन इन सारे न्यूमेरिकल्स को सॉल्व करने के लिए बहुत सारा कॉन्सेप्ट है जो आपको जानना जरूरी है. तो थोड़ा सा अगर आप पेशेंस रखोगे, आई विल कम टू द ईच एंड एवरी न्यूमेरिकल. गॉट इट? सो जस्ट सी ओवर हियर, मास्टर my dear friends, how to apply the master theorem and where to apply the master theorem means the first question is, when we should apply master. This is the major question, when we should apply the master theorem. So looking upon the recurrence relation, if the recurrence relation is following the particular format, then only we can apply the master theorem, otherwise not. What are those format? Let's try to understand. See over here, the master theorem can be applied if the recurrence relation is given into two different forms. One is called divide and conquer recurrence relation. अगर recurrence relation divide and conquer के फॉर्म में है, means what? See over here, take the example. T of n is equal to a t n by b plus f of, where a b are positive integer constant and f of n is equal to n to the power k for k greater than equal to 0. अगर कोई भी मास्टर थ्योरम इस फॉर्मेट में है देन वी विल से इट इज इन द फॉर्म ऑफ डिवाइड एंड कॉन्क्यूर. सो अगर इस फॉर्म में है तो हम लोग मास्टर थ्योरम अप्लाई कर सकते हैं. दूसरा फॉर्म क्या होगा, ठीक है ना, इफ इट इज फॉलोइंग द सब्सट्रैक्ट एंड कॉन्क्यूर, सब्सट्रैक्ट एंड कॉन्क्यूर recurrence relation. See why I am saying divide and conquer. Please try to understand, because every time the input size n is dividing by b. So here every time the input size n is dividing by b, constant value b, and that's why we are saying the divide and conquer. मैं दोनों में पढ़ाता हूं, ठीक है ना. मेरा स्पेशलाइजेशन है गेट, बट यूजुअली आई टेक फॉर द यूजीसी नेट. यूजीसी नेट में थोड़ा सा टफनेस लेवल कम होता है. गॉट इट दीपिका? सो मैं स्पेशली यूजीसी नेट बोल करके नहीं पढ़ाता हूं, मैं वहां पर बता देता हूं बच्चों को कि भाई आपको ये फॉलो अप नहीं करना है. गॉट इट? See, subtract and conquer. What does it mean? The recurrence relation will look like this. T of n is equal to at n minus b plus f of n. Again, here the a and b are this. A and b are the positive integer constant and f of n is equal to n to the power k. So this kind of recurrence relation is called subtract and conquer, because here we are subtracting some value. We are subtracting b over the input symbol n, and that's why we are saying this is the subtract and conquer. So just remember, if the recurrence relation is following this particular rule, then only we can apply the master theorem. Let me take one or two examples, then you will be able to understand. You will be able to. गेट के स्पेशल क्लास में लेते हैं, आप वहां पर सर्च करके देख लेना दीपिका. ओके, सो लेट्स स्टार्ट डिवाइड एंड. आप नेम से सर्च कर देना अजय दास गेट, तो मिल जाएगा आप. कॉन्क्यूर recurrence. भाई मैं एक बात फैक्ट बताऊं, मैं इतने सालों से पढ़ा रहा हूं ना, 8 सालों से पढ़ा रहा हूं, हर एक गेट का न्यूमेरिकल याद है, और ये भी पता है कि कब कौन सा न्यूमेरिकल करवाना है. क्योंकि मैं कोई भी न्यूमेरिकल बीच में अगर लेकर के आ जाऊं तो शायद आप उसके सॉल्यूशंस को अप्रोच ही नहीं कर पाओगे कि इस न्यूमेरिकल को कैसे अप्रोच करना है. दैट्स व्हाई आई नो कि व्हेन न्यूमेरिकल शुड कम एट विच टाइम, क्योंकि कॉन्सेप्ट के साथ साथ न्यूमेरिकल्स का भी पैरेलली चलना बहुत ही जरूरी होता है. और अगर कॉन्सेप्ट आपको पूरा प्रॉपर वे में पता नहीं है तो न्यूमेरिकल को आप अप्रोच नहीं कर पाओगे, ठीक है ना. एंड टिल नाउ आई एम आल्सो ऑथर ऑफ कंप्यूटर नेटवर्क एल्गोरिथम, डेटा स्ट्रक्चर प्रोग्रामिंग एंड द टीओसी. मैंने लगभग अपने करियर में 1200 क्वेश्चन कंप्यूटर नेटवर्क के लिखे हैं, लगभग 450 क्वेश्चन मेरा एल्गोरिथम का है. तो मैं जो भी आपको यूनिक टाइप का क्वेश्चन देता हूँ ये सब मेरा खुद का क्रिएट किया हुआ क्वेश्चन है। बहुत सारे क्वेश्चन है, डायनेमिक प्रोग्रामिंग हो गया, हफमैन कोडिंग हो गया, ठीक है ना। सो once you will once you will be connected with me you will be able to realize, okay। so बहुत सारे स्टूडेंट्स हैं जो IOCL में जॉब करते हैं जिसको मैंने पढ़ाया है, ठीक है ना। मैं कभी भी दिल्ली गुड़गांव में जाता हूँ तो वो सारे स्टूडेंट सबसे मिलने आते हैं, ठीक है ना। आपके आपने प्रयागराज का नाम सुना होगा, यहाँ पर जेके इंस्टीट्यूट है, यहाँ से लगभग 7-8 बच्चे IOCL में जॉब करते हैं। स्वीट्स के बच्चे हैं वो भी जॉब करते हैं, 1-2 बच्चे कोलकाता के हैं। मैंने हर सिटी में पढ़ाया है तो हर एक बच्चों से मिलना हो जाता है। कुछ बच्चे वेस्ट बंगाल स्टेट इलेक्ट्रिसिटी बोर्ड में जॉब कर रहे हैं, ठीक है ना। 2-3 बच्चे हैं जो वहां पर जॉब कर रहे हैं एज अ सीनियर इंजीनियर। तो जब कभी भी मैं किसी भी शहर पढ़ाने जाता हूँ ना तो मेरे कोई ना कोई बंदे चेले मिल जाते हैं, ठीक है ना, जो मेरे साथ टाइम स्पेंड कर सके। सो एक टीचर के लाइफ में इससे बड़ा अचीवमेंट कुछ नहीं होता है। वेन एवर यू आर विजिटिंग अ सिटी, द पर्सन or you can say the student to whom you have taught, they are coming to meet you. So this is the like very proud moment for every teacher. So just see, and I am expecting the same thing from your side. देखिए किसी भी एग्जाम को क्रैक करने के लिए दोस्तों एक चीज हमेशा याद रखना, किसी भी एग्जाम को क्रैक करने के लिए बस 2 ही चीज जरूरत है। इसके अलावा कौन क्या बोलता है वो उनके बात पे है। पहला है, ठीक है ना, लर्न द कॉन्सेप्ट, कॉन्सेप्ट आपको समझ में आना चाहिए। दूसरा, न्यूमेरिकल बनना चाहिए। अब इन दोनों के लिए बहुत बड़े प्रोसेस है। कॉन्सेप्ट को समझने के लिए पेशेंस होना चाहिए, किसी भी कॉन्सेप्ट को समझने के लिए पेशेंस होना चाहिए। आप कभी भी आप अपने लाइफ में देखना, एक छोटा सा बच्चा जो 8 महीने का है या 8.5-9 महीने का है और वो 10 मंथ्स की तरफ मूव कर रहा है और वो पहली बार चलना सीख रहा है, तो कभी भी आप उनको ऑब्जर्व करना, वो जो बच्चे होते हैं वो न जाने कितने बार गिरते हैं खड़े होकर के। अगर आप उसको काउंट करो डेली बेसिस पे, यू विल बी एबल टू फाइंड आउट ऑलमोस्ट मोर देन 1 लाख टाइम्स वो बच्चे खड़े होते समय गिरते हैं और फिर वो चलना सीखते हैं। जानते हो ऐसा क्यों होता है? क्योंकि उस बच्चे को बताने वाला नहीं है कि पेशेंस नाम का भी कोई वर्ड होता है। उसको पता ही नहीं है कि भाई इस दुनिया में पेशेंस नाम का भी कुछ वर्ड होता है। और इसलिए बच्चों के पास अनलिमिटेड और इनफाइनाइट पेशेंस होते हैं। वो जो ठानता है वो करता है। Dear friends, this is my Telegram number. If you have any query related with the concept, you can personally contact me 9264954515। देखिए लाइफ में ना डिमांड कभी भी कम नहीं होता है दीपिका। अभी आप सोचते हैं IIT मिल जाए, कुछ नहीं चाहिए। बाद में आप सोचोगे, ठीक है ना, इंटेल में जॉब मिल जाए, कुछ नहीं चाहिए। फिर बाद में आप सोचोगे USA में सेटल्ड हो जाए, और कुछ नहीं चाहिए। फिर आप सोचोगे USA में अपना बंगलो हो जाए, और कुछ नहीं चाहिए। तो डिमांड कभी भी कम नहीं होता है, इसीलिए सिर्फ मेहनत करिए। आगे क्या होगा उसको छोड़ दीजिए, भूल जाइए। अपना मेहनत शिद्दत से करिए। देखिए मैं आपको एक बहुत ही छोटा सा स्टोरी बताता हूँ। एक्चुअली आई एम ऑल्सो मोटिवेशनल स्पीकर। मैं बहुत जगह सेमिनार भी लिया है। गलगोटिया कॉलेज है, ठीक है ना, वहां पर भी लिया है। JLA मथुरा में सेमिनार लिया है। यूपी के बहुत सारे कॉलेजेस में मैंने सेमिनार पर्सनली कंडक्ट कराए हैं, ठीक है ना। MNIT है, NIT इलाहाबाद, यहाँ पर भी मैंने सेमिनार कराए हैं बहुत बार। तो कुछ चीजें हैं जो आपको समझना पड़ेगा, ठीक है ना। लाइक चलिए, मोटिवेशंस देने का बहुत टाइम तो नहीं है, ठीक है ना। आप एक काम करना, स्पेशल क्लास भी कंटिन्यू अटेंड करना। मैं कभी एक दिन टाइम निकाल करके 2 बातें आपको बताऊंगा, हाउ टू अचीव द गुड रैंक एंड द सेकंड इज हाउ टू गेट मोटिवेटेड। क्योंकि आपको कोई मोटिवेट नहीं कर सकता, ठीक है ना। क्योंकि जो दूसरे का मोटिवेशन होता है ना, वो मैक्सिमम 24 आवर्स तक सस्टेन करता है। आपके अंदर खुद आग होना चाहिए। अगर आपके अंदर खुद का आग नहीं है तो फिर कुछ नहीं हो सकता। और वो आग ऐसा बर्न होना चाहिए जब तक आपका गेट का एग्जाम नहीं होता है, आपका वो आग बर्न होता रहना चाहिए। देन यू विल बी एबल टू अचीव योर गोल। और एक बार आपने गोल अचीव कर लिया, आपका एक टाइम का मेहनत आपके लाइफ टाइम के, ठीक है ना, सैलरी का एक जरिया बन जाएगा। तो थोड़ा सा एक बार बस मेहनत करिए, एक बार आपको फोड़ करके दिखाना है जो भी आप लाइफ में चाहते हो, और उस आप एक बार अच्छे आईआईटीज में चले गए या अच्छे एनआईटीज में चले गए, वहां से जो जॉब लोगे वही जॉब आपके लाइफ टाइम चलेगा। ठीक है ना, तो मेहनत करिए। ओके, सी ओवर हियर। See, my dear friends, what I have told you, the divide and conquer recurrence relation. What is the format of divide and conquer? T of n is equal to at n by b plus f of n. Now I am writing some of the recurrence relation. You have to tell me whether these recurrence relation are following the conditions of divide and conquer or not. Already I have told you that a and b are the positive integer constant, and f of n will be written as n to the power k, where k is greater than or equal to 0. So I am writing the first recurrence relation. T of n is equal to 5t n by 2 and plus n square. So of course this recurrence relation is following the condition of divide and conquer. The second I am writing in this manner. T of n is equal to 5t n by 2 plus n by log of n. My dear friends, this is not following the condition of divide and conquer, because here f of n should be in the form of n to the power k, where k is greater than or equal to 0. But you have written n by log of n. So this is not following the condition of divide and conquer. Are you getting my point or not? Third example I am considering. T of n is equal to 2t root under n plus n. Also this is not following the condition of divide and conquer. And T of n is equal to 2t n by 2 plus n. This is following the condition of divide and conquer. So I hope you know where to apply the master theorem. So these are the two different recurrence relation where you can apply the master theorem. For remaining you have to follow some other approach. For the remaining you have to follow some other approach. Either you can follow the substitution method or you can follow up the recursive tree method. So when we will follow the substitution method and the recursive tree method, I will tell you later on. क्योंकि देखिए जब तक आपको हर एक मेथड का बेसिक पता ना हो और इन डेप्थ पता ना हो, तब तक आप ये जज नहीं कर सकते हो कि किस प्रॉब्लम के लिए कौन सा मेथड अप्लाई करना सूटेबल है. Got it, everyone? So let's see the divide and conquer recurrence relation. Okay, divide and conquer recurrence. See, whenever I am writing a recurrence relation in this form, a t n by b and plus f of. So what this particular part will derive. देखिए इसका फिजिकल सिग्निफिकेंस भी जानना जरूरी है, अदरवाइज आप सिर्फ प्रॉब्लम सॉल्व कर पाओगे, आपको लॉजिक कभी भी समझ में नहीं आएगा. इसका फिजिकल सिग्निफिकेंस इसलिए जानना जरूरी है क्योंकि कुछ ऐसे न्यूमेरिकल्स हैं जहां पर प्रोग्राम गिवन होते हैं और उस प्रोग्राम का आपको टाइम कॉम्प्लेक्सिटी फाइंड आउट करना पड़ता है. आर यू गेटिंग माय पॉइंट? लाइक आई एम जस्ट गिविंग यू अ एग्जांपल. जस्ट सी ओवर हियर. सो जस्ट लुक अपॉन दिस. This is the program given, and what they are asking the corresponding recurrence relation. So in this kind of problem you have to understand how the divide and conquer is basically happening, and what is the meaning of divide and what is the meaning of conquer. So ये जो पर्टिकुलर पार्ट होता है, ठीक है ना। ये जो पर्टिकुलर पार्ट होता है इसको हम लोग बोलते हैं डिवाइड टाइम. व्हाट वी आर सेइंग, दिस इज सेइंग डिवाइड टाइम, and this is calculated in the form of n to the power log of a on the base b. इसको हम लोग बोलते हैं डिवाइड टाइम एंड इट इज कैलकुलेटेड इन द फॉर्म ऑफ n to the power log of a on the base b. Let's see the real example how it is coming out to be. Let's see the real example. ठीक है, चलिए देखते हैं. See, suppose if I am giving you a recurrence relation like this, t of n is equal to 2t n by 2 n plus, ठीक है ना. तो ऑफ कोर्स यहां पर f of n में हम लोगों ने क्या कंसीडर कर रखा है, n to the power k where k is equal to 0. ठीक है ना. तो देखिए यहां पर क्या है, दिस इज द एक्चुअल इनपुट साइज एंड वी आर डिवाइडिंग द इनपुट साइज 2 टाइम्स अगेन एंड अगेन. सी ओवर हियर, दिस इज द एक्चुअल इनपुट साइज n. ठीक है ना. और इस रेफरेंस रिलेशन को कॉल करेंगे तो दो फर्दर रेफरेंस रिलेशन कॉल होगा, n by 2 एंड n by 2. अगेन इसको कॉल करोगे तो फिर से दो रेफरेंस रिलेशन कॉल होगा, n by 2 स्क्वायर एंड n by 2 square. Similarly, it will call n by 2 square and it will call n by 2 square. और इस तरह से बराबर अगर हम लोग डिवाइड करते जाएंगे तो कभी ना कभी ये वैल्यू 1 होगा, मीन्स पूरे लीफ नोड पे ये वैल्यू कितना आएगा, 1 आएगा. yes or no all of you? in entire leaf node this value will become 1, क्योंकि अगर आप n कोई भी इनपुट साइज लेते हो तो कभी ना कभी अगर बार बार आप इसको 2 से डिवाइड करते रहोगे तो कभी ना कभी ये इनपुट साइज जो है ये 1 के इक्विवेलेंट हो जाएगा, 1 के इक्विवेलेंट हो जाएगा. एंड इन दिस एंटायर प्रोसेस हाउ मेनी रिकर्सिव कॉल्स आर देयर, वी आर ट्राइंग टू कैलकुलेट नंबर ऑफ recursive calls. We are trying to calculate the number of recursive calls. All of you, we are trying to calculate the number of recursive call. भाई ये तो रिकर्शन ही है ना. रेकरेंस रिलेशन मतलब क्या, एक ऐसा रिलेशन जहां पर रिकर्शन है. तो एक बार यहां पर रिकर्सिव कॉल हो रहा है, एक बार यहां पर हो रहा है, एक बार यहां पर हो रहा है, एक बार यहां पर हो रहा है. इस तरह से बहुत सारे रिकर्सिव कॉल्स हो रहे हैं. इस तरह से रास्ते में होते हुए ये बहुत सारे रिकर्सिव कॉल्स हो रहे हैं. सो माय डियर फ्रेंड्स, हाउ मेनी रिकर्सिव कॉल्स आर देयर, हाउ टू आइडेंटिफाई. इसको आप ऐसे भी लिख सकते हो या इसी को आप सेपरेट कर दो, कोई प्रॉब्लम नहीं है. ठीक है ना. लिखने का तरीका है टी एन बाई 2 एंड प्लस अगेन टी एन बाई 2 and plus 1, 2 times we are making the same recursive call. Okay, now see how many recursive calls are there. So ये एक ट्री की तरह दिख रहा है ना आपको, and this is nothing but a binary tree. बाइनरी ट्री, और किस तरह का बाइनरी ट्री है, फुल बाइनरी ट्री. yes or no? This is nothing but a binary tree and it is a full binary ट्री. और जितने नंबर ऑफ इस बाइनरी ट्री में नोड्स हैं उतने ही रिकर्सिव कॉल्स होंगे. यस और नो? सो नंबर ऑफ रिकर्सिव कॉल इज इक्वल टू नंबर ऑफ नोड्स. यस और नो? द नंबर ऑफ रिकर्सिव कॉल इज इक्वल टू नंबर ऑफ नोड्स. सो अल्टीमेटली फर्स्ट ऑफ ऑल यू हैव टू आइडेंटिफाई व्हाट इज द हाइट ऑफ द ट्री. भाई किसी भी बाइनरी ट्री में फुल बाइनरी ट्री में नंबर ऑफ नोड्स कितने होते हैं भाई, आपको पता होगा, आपने डेटा स्ट्रक्चर पढ़ा है. क्या होता है, 2 to the power h plus 1 minus 1. yes or no all of you, where h is the height of the tree. in any full binary tree, the total number of nodes is 2 to the power h plus 1 minus 1. So if we are able to identify the height of the tree, we can find out the number of recursive calls. So height of the tree क्या होगा, तो चलिए देखते हैं. टोटल कीज या इनपुट साइज n है और बार बार n को आप 2 से डिवाइड कर रहे हैं, 2 n by 2 square and up to dot 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 n by 2 to the power k. तो यहां पर हम लोगों ने कितने टाइम्स डिवाइड किया है, k टाइम्स. कितने टाइम डिवाइड किया है, k टाइम्स. सो यही k का वैल्यू हाइट हो जाएगा. सो कभी ना कभी ये वैल्यू 1 होगा. In this situation, k will become log of n. Yes or no? K will become log of n. So the height of this tree is nothing but log of n. So finally, what we can write? The total number of nodes is equal to 2 to the power h plus 1 minus 1. This implies 2 to the power log of n plus 1 minus 1. You can write 2 into 2 to the power log of n minus 1. You can write 2 into n minus 1 and you can write order of. Got it? You can write order of. So the total number of recursive call is equivalent to the order of. Total number of recursive call is equal to the order of n. Got it? Everyone. बात समझ में आ रहा है? All of you. And इसी बात को मीन्स जो मास्टर होगा, जिसने भी मास्टर थ्योरम दिया होगा, उसने क्या सोचा होगा, वो कुछ इसी तरह से अपना एक थॉट जनरेट किया होगा. देखिए अब मास्टर थ्योरम पे हम लोग चलते हैं. मास्टर थ्योरम अगर ये रेफरेंस रिलेशन है, t of n is equal to 2t n by 2 प्लस 1. मैंने आपको अभी बोला था कि मास्टर थ्योरम क्या बोलता है, दिस इज नथिंग बट द डिवाइड टाइम विच इज नथिंग बट द नंबर ऑफ recursive calls. In real implementation we have analyzed and this is calculated in the form of n to the power log of a on the base b. So in this example, what is the value of a? 2 and the value of b is also 2. So this one will become order of n. This one will become order of n. Got it everyone? This one will become the order of. क्लियर है बात? तो देखिए अभी हम लोगों ने स्टार्टिंग में, आपको याद होगा स्टार्टिंग में सबसे पहला प्रॉब्लम हम लोगों ने यही सॉल्व किया था, ठीक है ना. और उस समय का सॉल्यूशंस जो था सब्स्टिट्यूशन मेथड से कॉम्प्लेक्स था. उस समय का जो सॉल्यूशन था जो हम लोगों ने यूज किया था, कौन सा मेथड? सब्स्टिट्यूशन मेथड, जो कि काफी कॉम्प्लेक्स था. अब इस मेथड से आपको टाइम ही नहीं लगा. यू कैन कैलकुलेट बाय योर ब्रेन. You no need to take the pen and paper. So as soon as you will learn the concept, gradually the calculating time will be reduced. जैसे जैसे लाइफ में आप आगे बढ़ते हो ना, आपके अंदर एक क्या बोलते हैं उसको, एक मैच्योरिटी लेवल क्रिएट होता जाता है एंड दिस इज कॉल्ड द मैच्योरिटी लेवल. ठीक है ना. रिड्यूसिंग द टाइम टू थिंक अबाउट एनीथिंग इज जस्ट नथिंग बट द मैच्योरिटी लेवल. Got it everyone? So कहीं ना कहीं मास्टर ने इस तरह का ही अप्रोच यूज किया है. माय डियर फ्रेंड्स, ये किसी भी बुक में आपको नहीं मिलेगा. किसी भी बुक में नहीं मिलेगा कि मास्टर ने ये कैलकुलेशन कैसे किया था. बट दिस इज द एक्सप्लेनेशन. दिस इज द एक्सप्लेनेशन. क्लियर? बोलो भाई, मजा आ रहा है? So this is the divide and conquer recurrence relation and this part will be calculated as n to the power log of a on the base b. You can take the real example also. For this you can take the real example. See, सपोज अगर हम लोग n का वैल्यू लेते हैं 8, तो क्या होगा, 8 को दो पार्ट में डिवाइड करिए, 4 4, अगेन इसको दो पार्ट में डिवाइड करेंगे, 2 2, अगेन 2 2, अगेन डिवाइडेड 1 1 1 1 and 1 1 and again 1 1. So total number of recursive call will be how much? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So here number of recursive calls is equal to 15. You can write the 15 in this manner, 2 into 8 minus 1. So this is nothing but 2n minus 1, and this implies this is the order of. Got it? So in this means with the help of real example you can think about this, not a problem at all. Okay. My dear friends, it will take a lot of time whenever I will explain the divide and conquer mechanism. So do one thing, on the 25th November, I will take next marathon series of algorithm, and I will continue from the same place. Algorithm at the rate of 6. Is that fine? And from there we will start from the divide and conquer. From there we will start from the divide and conquer, and we will continue the session. Is that fine, all of you? So my dear friends, if you are liking my video, then please like this particular channel. Okay, and if you want to get the subscription, never forget to use the code IFAR to get minimum 10% discount. Press the bell icon button for all notification, and never forget to subscribe this channel, and put your valuable comments after the lectures. Put your valuable comments what you are thinking about these lectures, so that many students can get the inspiration and they can also join. If you have any doubts, any like related numericals you want to solve, if you are not able to solve, you can personally contact me on my telegram number, that is the 92649545. Okay, thank you very much guys. No, Deepika, daily I am taking the lecture on the YouTube, but on the different subjects. I am taking the lecture at the 5 p.m. and 10 p.m. Sorry, from the tomorrow. Today is the Sunday, Saturday. So you just note it down. Daily I am taking the lectures at the 5 p.m. and the 10 p.m. on YouTube. So you can attend over there. Yes, Suresh. Okay dear friends, bye, take care, good night, मस्त रहिए, मेहनत करिए, लाइफ में आगे बढ़िए, यही मेरा ब्लेसिंग है आप लोगों के लिए, ठीक है ना, खूब मेहनत करिए, क्योंकि मेहनत करने वालों की दोस्तों कभी हार नहीं होती. बाय, टेक केयर.